Okay, so here is from our excellent Haxe manual to recapitulate on that, an illustration of how it all works. So basically you got your source code coming in, and then it's being passed, and then you have the abstract syntax tree resulting from that. That's what we consider expressions. And then that's where things actually start getting complicated, because they begin becoming typed by the typer, and as the typer types the abstract syntax tree, it discovers that certain expressions can only be typed by actually calling macros first, unfolding them, and then it generates something called the typed AST, which is only vaguely reminiscent of the kind of stuff that you've actually sent into the compiler, because there everything is already type checked, so it actually makes sense. Like if you have a chunk of typed expression of typed AST, then this is most likely going to be valid code down the line, except if the backend kind of does weird things. But yeah, often, well, let's just pretend that it's always valid. Okay, and so then basically the type dust gets passed down to the generator, and then yields the actual output. Now this is a bit simplified, because in fact between all the boxes, well, between many of them you could actually draw more arrows. Like it's possible to take a piece of typed AST, turn it back into untyped AST, and then round trip it through the typer again. Often that results in weird things, like for example, if there's an expression that contains a call to an inline function, then by typing it, it is actually going to be converted into the code where it's inlined. But the inline function may actually have had access to some private fields that the resulting code did not have. And if you try to round trip that, then you will get stuff like this is private access and you shouldn't be doing this and blah, blah, blah. But sometimes as a means of last resort, it's useful. Or if you want to take code from another class that does not belong to you and insert it into your own, then you can take its type fields and inject them into your code. Not always an intelligent thing to do, but yeah, you can. All right. After Francis asked me some questions, I would like to talk a bit more about about typed macros or type-aware macros. Like, because the other stuff I showed was always just looking at the structure of expressions. But what makes macros really powerful is their possibility to look at the type that things have. For example, does anybody know the Haxe Web Dispatch class? Anybody seen it? The router? Yeah, awesome. So it is a class from the standard library. It basically allows you to take a URL and a bunch of parameters that you get into your application and have that like invoked onto a certain object. So like basic routing for the web is done through that. And the way it works is by actually examining the type of the target that you're giving it, and looks, okay, which functions are defined, and then it's able to generate the code that maps certain URLs to certain fields. So like that's one application, or Kawa has an MCLI which does about the same thing for command line interfaces, where also you can just say this is my interface class, and you run a specific macro on it, and then depending on the type of that class, code is generated that allows mapping the parameters that you type in onto the onto the class that actually implements the functionality, and you don't have to pass the parameters yourself. It's just the macro that does that, because it does have all the type information. It knows what functionality you have, and then it follows some convention to convert that into parameters. All right. So to look at that, I don't know. Well, maybe here's the best thing. Yeah. So to look at this again. So this was the expression class that we enum that we had, which defines all the different kinds of expressions that there are. So in this whole package, you will find a lot of those things. And then there's a so-called complex type, which defines the different kinds of types that you can have, syntactically speaking. And then you have the typed counterparts, which are called, how could it be otherwise? Where is it? Type, and also typed expression. Now, this is the important one. So a typed expression looks a bit like the expression, but it does have a position and an expression field, which contains like the actual structure, but you may notice there's an extra field T, which is the type. Like every typed expression has a type already determined and known, and so this is how the compiler actually keeps track of those things. And you can see that many of those things are the same. You see a couple of new ones, like tlocal, for example, is something that does not exist in the parsed AST, because their identifiers are just identifiers. They could be meaning a global field under a name, or maybe just an instance field or something like that. But they could be meaning a variable, and in the type AST, this is resolved. You already know what it is. Like it's probably going to be a tlocal or a tfield or something of that kind. But it's very similar in structure, only a few things are a bit different. And then another part is actual types, which are somewhat different from the complex types. These are the types as they are written down by you. These are the types the way the compiler has interpreted them and looked through them. So these are like type defs, class instances, functions, and all this kind of stuff. And oftentimes you will want to examine those. You can, for example, at any time do something like, let's just try this with an example experiment. Type macro, here we go. So, okay. So in here we just have a class, and let's just define a macro, and let's call it macro static function get fields. All right, and so what we want this thing to do is give us all the known fields of the expression that we supply to it, but not through means of reflection, as we would do it in JavaScript, for example, where you just take the object, or in Haxe we would use reflect.fields to look at the fields that the thing has at runtime, but to use its compile time type and determine the fields then, and to just generate the code that evaluates to the same thing. So we can, see this right here. And the first thing we're going to do is, so context basically has most of the compiler functionality exposed for you, and you can do just something like context type of E, and you see that the return type is type, so this fella. There we go. So yeah, like enums or instances or all this kind of, you know, the counterparts. So, and then we're left with switching through this, and we can, for example, assume it's an instance, meaning that it's a class. And the second parameter is for its type parameters that it has, which don't really interest us if we just want the field names. So let's, you know, keep it minimal. In here, we're going to emulate compiler behavior. So we can now return something. And if we look at this inst possibility that we have, which is defined here, then we have a reference to a class type. And these references actually enable the compiler to expose its information in a lazy way. Unless you call get on a reference for the first time, the value is actually never translated into hex representation. Because I mean, all this information is there for the compiler, but translating it to a form that the macro interpreter can handle requires a lot of time and mostly memory. Because in OCaml it's just like really tightly packed stuff that then needs to be translated into something similar to Nico objects. So you will find that particularly in the type world, where there's even more information in the just simply parsed world, you will encounter a lot of references so that your macros can still run at fast speed. Like information that you don't need to access will not cost you anything because it's not there yet. I mean, it's as good as there, but until you get it, it doesn't incur any overhead. So if we look at this, we can like get the class type, and we can look at its fields, which is also a reference. So we will need to get that, and it's going to give us an array of class fields. So why not do this? Field, and then we see, all right, this is information that a class field will contain, so whether something is public or what its type is, or all this kind of stuff. But all we actually really wanted to have is the name. Okay. Now I'm tempted to take a shortcut, but let's not. Now this is, we have all the field names, and now the only thing that's left to do is actually make an expression of that. So we're just going to push this in here. Then we can say something like expressions push macro. So this is a value, and we want to convert it into the expression that evaluates to that value, so to speak. So we have to do this, and then we're left with an array of expressions, and we can, let's just do this by hand. We can return an array declaration, which takes an array of expressions, and a position, where we will take the original position. Okay, and in theory, this might just compile. Or maybe not, because this is why. Okay, and I think, very helpful. Okay, but yeah, tracing unfortunately is not that comfortable in JavaScript necessarily, but we see that on the console we actually get an array of 11 elements, which are really the compile time parts. So just to make that clear, like we could take the variable here, foo string, we could initialize it to null and ask the code to give us the fields, and we get the same result. Let's just do this differently. Okay, and alert. so we don't have to open the console. All right, very professional. Okay, so we have this right here. Okay, so, and this really depends on the compile time type. Now we're not handling all the cases. There's another one that, for example, we might want to handle. What about anonymous objects? The anonymous types have fields too, okay? So this is a reference to an anonymous type, okay? So let's see, anon get, so that's the anonymous types. There are the fields, which again, which are there already. Okay, so let's just make this a small function real quick. Make fields and at a position, so to not have to write everything 100 times. There's always time for code formatting. And there we go. So this just kind of, oh yeah, this is Flash developing, very helpful. Okay, so this basically does what we want here, make fields, and then we can call it in this way. Take the fields and the position, and down here we can do the same thing, make fields, and use the same position, I suppose, and hope that it compiles. I'm sorry. Okay. Sometimes when you're doing macros, it happens that functions that you create that are only supposed to run at macro time in the macro context, they somehow leak into the outer context. So just to help with that error message, which may be very cryptic, if you see this kind of stuff happening, what's actually happening here is that the compiler is trying to compile make fields for the JavaScript context. And this little fella here, the V that's underlined in red, as you probably don't see, this one, is a shorthand for context make expression, which takes a value and converts it into the expression that evaluates to the value. Okay, so that's what happened. And in that case, the easiest thing to do is to wrap it in an if macro and move along. Okay, so this should still work, and it should now work also for saying, I don't know, length. Yeah, length is an int. So this should be a valid value for a string, right? Okay. Length default now. What did I do? Okay, so now we have the same value, and depending on its type, like the first alert is just actually going to give us back length, because we're just looking at the what is the same value at runtime as different expressions with different types, and depending on that we get different results. Okay. So, isn't that nice? Okay, and now that would indeed allow us, like if string were a sensible API, in the sense, like if it gave us real functionality, then we could, for example, write a macro or such as MCLI, which would allow us to call methods through command line arguments or stuff like that. Like we could generate all this kind of stuff depending on that. Now with string it doesn't really make sense, but if we just said class my API, and I don't know, public function foo command, oh yeah, let's just call it foo, and public function bar, and we just say var API is equal to a new API. And then we look at the fields, then indeed we are going to get the right ones, I hope. Okay, we can't. We get foo and bar, and now of course that's not immediately useful, but what we could be doing in here, like for example, if you look at the class fields, then you could only pick up the fields that are public, and then only pick up the fields where the type is a T function, so it's a method, and then actually generate code from that which just examines the parameters that come in, and then generates the calls to the functions, so that, for example, this is a JavaScript project, but so that my command foo would actually call the method foo, and my command bar would call the method bar, and all that kind of stuff can be done based on that. Okay, I had a similar question which also revolves around the typed API. So your general friend here is this context class, which allows you to examine many things, such as the type of an expression, or for example, when you're being called, then there's also something that I often find very interesting, get expected type. So like if your macro is being called and you want to know what type is expected, then you can just ask the compiler. So you could write a macro which just says, yeah, well, let's just do this. Coerce 5. All right, so we just want to kind of have JavaScript semantics in Haxe. Awesome idea. So we just say, all right, this is, yeah, that's a macro, and then we can just go macro get expected type. Let's just throw that. Okay, and so it tells us it actually wants an integer, and that's pretty neat. And then we can, by using Haxe Macro tools, yeah. So in here, you don't get to, there's a lot of static extensions that add other useful helpers to all this kind of stuff. So we can actually do this. So then it gets thrown as something rather readable. And I'm really just doing this because examining different types under the form that the compiler gives them to you is sometimes tedious. Sometimes it's just faster to convert it to a string. It's not necessarily very safe, but yeah, humans are rather good with text. So, okay, and so we can now make a switch statement, context type of value to string. Okay, and so now we can say, for example, if the expected type is an int and the given type is a string, I'm sorry. Everybody knows tuple pattern matching, basically, all right? So we have the two things and they are matching. Oh, okay. Just don't want to be doing too many things at the same time. Okay, so in this case, the value that we have is a string, and the thing that we want to get is an integer, and what we can do then is macro standard parse int value. So we're constructing a new expression where the one we are getting is inserted into a call to standard parseInt. And we can have a default case, and there we can say context, again, error, cannot coerce, I don't know, let's give them names. Cannot coerce B to A, and we can use the position here. All right, so now, I'm sorry, I have to return something, of course. Okay, very useful. Yeah, just to show that it is actually doing something. Okay, so we've got this int called 5, and so we might, for example, say we want to coerce this this float to an int. Then it will give us at the right position, cannot coerce float to int, and then we can go back to our macro and say, all right, in this case, we would do standard int of value. And then it's still 5, yay. Yeah, exactly. Or we could do it the other way around, like if we have an integer and we want a string, then generate the standard string automatically and all this kind of stuff. So this actually reacts on the type. And it's even more interesting, like if you react to the structure of the type, and that's what expected type is basically for. You can get a lot of other stuff, like, for example, the local class. That's the class that you are currently being called in. This is generally quite interesting. It's most interesting in the case of build macros, to come back to a question that I was asked during the break. And in that case, you can get the class that you're currently building, the class type that it has. And then if you want to get the different type parameters, then you see class type is in fact a base type, which has parameters. So either it's in here, a type parameter, again, has a name and a type applied to it. Or if you want to get the type parameter used by the interface that has the build macro, then you can indeed look through the interfaces here. So like the class being built, you look through its interfaces until you find the one that owns the build macro. That again is going to be a class type that you can look into the parameters, and then you can know, for example, like, I mean, if you had an interface here with an auto build interface, implements magic macro, and I don't know, I mean, this has some kind of type parameter. To get to that, you would kind of start with the class that you're currently building, context a local class, then go into the interfaces, and look until you hit the one with the right name, basically. Sometimes it can be a little tedious, but I mean, all of those things are values, so the same things apply that apply for general programming. You can just write yourself some helper functions that do this and then just reuse that. I mean, I think there's a couple of libraries floating around that actually allow you to do these kinds of stuff, because it's something you get to do very often, in fact. Yeah. Okay. So that was that. Does anybody else have something else? Yeah, another nice.
Several questions. First of all, is there any way to save the code generated by macro as Haxe code, especially for debugging?
Especially for debugging, yes. So yes, generally there is. Okay. So in this macro, yeah, I'm using this tools, which unfortunately is not here. But what this does, for example, is to add to string function to almost anything that there is. And what you can do is to actually just call to string on something that you generated and save that somewhere. And the result, at least for the non-typed things, is valid hex code. Most of the time. And what's, I mean, this depends on what you want to do. If you want to have the hex code to then work with, that's one thing. Another thing is if it's for debugging purposes, for example. So, like in that case, you can do some fun stuff. I hope this actually works. So, like in Tinkerbell, for example, there's a lot of syntactic sugar going on, and sometimes I step on my own feet and I want to know what's actually being generated. And so in that case, I think there's this explained metadata that one can add. Okay, or maybe not. References. No. What's it called again? Okay, so it's not in there, it's in here. Yeah. Verbose. Okay, I think it was this one. Also now. Okay, well, essentially, probably not working now. But what you can do, I mean, I find this very helpful, is you can actually generate compiler warnings, even, at a specific position. And to just put in place a mechanism that will allow you to do that, so that the code that interests you, you can annotate it with some metadata. And then at the different fields of the class, for example, that is being mangled with macros, you just emit compiler warnings at the position of the field. So you have actual real mapping. Like in your IDE, in Flash Develop, you can click on something and you can see where it comes from and all of that. That's actually in many ways even, well, for debugging, I think it's better than just printing out the code, because you have the mapping. But if you just want the code somewhere, for example, because you want to cut down your build times or something like that, then you can just use toString on the fields that you have generated and store that somewhere and take it from there. Okay. Does it produce printable and stuff? Yeah.
It generates a new folder, and in there you can see. I think that the default is done equals 3, which is easy to parse
for humans.
Yeah.
Okay. Let's.
For a human being to parse, but if you.
Let's try this. So yeah. Dump equals pretty?
Yeah, it was pretty. Yeah.
So, yeah. Okay, so it should, yeah, here we go. So, in here we have the whole, okay. Well, you see that it's not perfect. There's a lot of brackets or braces going on. But it gives you an idea of what is happening.
Can you open the API?
I'm sorry. Which one?
Your class.
Yeah, where is it? I'm sorry? Ah, here. Yeah, okay. So you see a lot of empty functions. Like the notation is not perfect, but I mean, it's well possible that in Hex 3.3 this has improved. Maybe, I don't know. I hope so.
One more question. can create classes.
Sorry?
Can create new classes.
New classes, yes. So essentially, there is in context again, which is a class well worth studying. Just, I mean, I know it's probably not that interesting to just read through API documentation, but the one of context is really worth your time. And in there you will find define type and define module, which allow you to define either just a small type or a whole module with multiple types. Define module is way more powerful in that it also allows you to add using and import statements. But essentially, yeah, you can just generate classes out of thin air or at random or or from I mean, it's something that I'm still struggling to get to go, but essentially a thing that you could try would be to pass TypeScript type definitions at compile time and generate the files on the fly, so that you can just get all that kind of stuff and use it from within your Haxe project and get auto-completion for the whole JavaScript ecosystem. But yeah, parsing TypeScript is somewhat difficult. The one great library that we have uses macros, and you can't have macros and macros, and yeah, but in principle it's possible. Okay. All right. Some other stuff? Yeah?
Just to show, for example, mobile devices, like some issues that if you use phone type for coordinates, so like jump each time, so we use int and shoot each time, traffic to most people's right, and for example,
So you mean the macro would actually go and change the type on the classes that you don't own?
Yeah, for example, right type change some variable type.
Okay. Do I?
Using macro.
Sorry?
How to put mechanism using macro.
Okay. Well, I mean, there's many ways to go about this. Like, for example, in a project that we worked on recently, we actually put in a global build macro that runs on the whole code, including the standard library, to fix the fact that unsigned shift down, I'm not very good with left and right, is broken on JavaScript if you shift by a negative value, which probably doesn't make sense to do, but anyway, it happens. And then the result is kind of specified everywhere except on JavaScript, where you get the wildest differences. And so we did make a global macro that actually looked at the few places that this operator occurs and wrapped it in a call that would just examine the different cases. And in that case, we found it practical because it was like in the whole code base, in the end, it just touched 80 locations or something like that. It was just for one case. But of course, like the more things your macros touches, the more things you can destroy. Oftentimes, like when a native interface that you work with seems or feels broken or not very useful, the best thing to do is just to define an abstract over that interface and let it do the work for you. So there you can define X and Y with the types that feel good for you, and the setters that are good for you, and let it do the clamping of coordinates or casting or whatever it is that you need to do. And then write your code against that type instead of other types.
Yeah, if you work, for example, just for Asha,
Yeah, I mean, it's on general, I'm not sure I can really answer the question. Because I mean, I'd have to think about it a lot more, I guess. Because, I mean, sure, it can work, and you can try. I mean, that's the only way of knowing for sure, right? But yeah, I mean, I wouldn't go as far as saying don't do it, because it might be just the right thing for you. But Haxe offers a lot of other tools. Like you could define a new numeric primitive that somehow has its own casting rules from and to float, and then change the type to that. Or you can use abstracts or whatnot. You can use abstracts and macros in combination, which usually is like very, very powerful. Like if you use those two together with implicit casts, then it's like ultimate power. Which nobody understands, but yeah. So long as it works, nobody complains. Okay. Yeah.
Is there any way to exclude type from type? To add some other class, for example, with the same name? So there's a possibility to exclude it just from final code for JS, for example. But it seems that it still remains in typer and you can add another class with the same name.
Okay, so you have a class that is there that somehow gets found during compilation, and you want it removed. And well, I suppose you can't delete it, right? Well, you could delete it. I mean, it depends. Like you can take a global build macro essentially, and or yeah, you can even take a global build macro where the filter for on which functions it runs, on which a class it runs, is only that class. Like in this, hang on, I'm sorry. It was this one, yeah. So you have this add global metadata, which actually adds a global build macro. And the empty string that you have there is like a filter. Like it says on which packages to do it.
I understand syntax.
Oh, sorry.
You have a case when some interface, there's this meter with marker. And it is handled in some way that it understands that this class should be removed, for example, or replaced with another class that will be generated later.
Okay.
And that first base type there, which has method exclude.
Okay.
And this excludes
it from generation, yeah. It turns it into, yeah.
But the typer itself still has this type in it.
Yeah.
So you will get error if you will try to define the type of the same name.
Okay. So what? Yeah.
To remove it from the type, or the moment when it was typed, it's.
I understand. It depends on how much information you have. If you already have a, well, no, actually no. If you want to replace a class that was already typed by one that comes second, and they are compatible, are they?
I can describe the case, but
Okay, okay. Assuming they are compatible, assuming just assuming the class that comes second is compatible, then what you would do is exclude the first file and give it a native metadata so that in the generator it is remapped to the second.
you can't modify it.
Why?
In our case, that's.
No, like in at macro time, you can take a class that is already typed, and you can add metadata to it. Like just when the second class is being typed, you can load the first one, the one that you don't want to have, the old one. You can get its class type, you can get that class type's metadata, you can add a native tag to it that remaps it to the second one. So like if you add, well,
this will work after the first type was already typed.
It will, yes. Because the native metadata is something that gets processed in the backends during generation. If a class has a native metadata on it, then actually it's a job of the generator to then replace it when it's generating code. Technically, this could be broken somewhere, but I think currently all backends implemented correctly. Okay? So that's one thing. But this is assuming that the classes are compatible. Like if you still have code that's calling methods on the old class definition that don't exist on the new one, then it's going to explode at runtime. But if they have the same interface basically, then everything's cool. If they don't, you're probably screwed. Or you have to have some idea ahead of time which interface you want to be implementing. Like if the class that comes second has a way of suggesting to the first class which interface it should be or something of that kind, or you can attach it. I mean, I don't know. We'd have to discuss the specifics, I guess. But I'm sorry? Well, if they are compatible, yes, and there's many possibilities, of course. If they are not, then yeah, I'm not 100% sure. But yeah, if you explain all the details to me, then maybe I can give you an answer that.
Another question: is there a way to expand the stack size for typing?
Is there a way to expand the stack size for typing? I guess you would have to open an issue on GitHub. Or do the converse, try to get your stack size.
Sometimes it's possible, and we finally work around with this, but it is not safe because it uses string to have a name of a class.
Okay.
And it is verification inside verification to get the real class just in time when you need it. It's runtime, so not to call.
Okay. Well, actually, a method that I'm using sometimes to not have a lot of very complicated macros is to, or with too much recursion, is to pass through multiple stages where the code that you generate will again call other macros. This also keeps your stack size down, and you also have many intermediary stages that are vaguely readable, like because the first layer interprets a type and then generates some code, which then contains calls to macros or stuff like that. Like for example, if you have a build macro, then syntax level transformations could happen later. It depends a lot, of course, on the use case, but you can break it up. The code that you generate might be macro calls. Yeah.
In our case, it was short generation of some kind of type info for runtime injection. So we had to cover too many classes. So one was reading the types of arguments for some of its function, and it calls conjected types for the argument type, and the second one was reading these arguments and...
Yes. I mean, you can do all that, but for example, the macro context is a full running program. So like, for example, if you can even take very complex data and pass it from one macro call to another. You just take the type of the data, you take a big lookup table, In there you create a new key, call it an integer, like 3. And then you generate a macro that is called just with the constant of 3. And then that macro can go back into the table and restore all the information it needs. But your stack is flat at that point, because you re-enter the same context, but you just get rid of all the recursion. But you can carry as much information as you need between two macros. And it's one part of it is in the AST as just a constant that helps you refer to the context that you have created, and the other thing is just a static variable that lives in the macro context. Okay. Yeah, maybe we'll try not to lose everyone else. Okay. Other questions maybe? Then I got a little brain teaser from you. That we might want to have a look at also. Well, this is now not very aptly named, but okay. Let's remove this to keep compile time down. So as far as I understood it, this was it. In the CFFI, you have some kind of syntax that allows you to load native functions. I think I vaguely remember something like this. Loader. Then I imagine here comes some native name. So name of the func. And then here comes some peculiar way of denoting the signature. So this means there's 5 integers. Is that right?
Yeah, 4 plus.
I'm sorry, a 5th one? No.
There's, the number of arguments plus 1 extra again.
Okay, so an extra routine. So this will basically, all right, I'm being lazy here. So basically, this is what the III means, all right? And there's a way of loading native functions, and the III is, I think, needed by CFFI to be able to box the things right, or get the arguments in right. No? Okay, so maybe some type of callable something with the signature or with that. Wonderful. Okay, and so now the question is, how can you make this nicer? I mean, there's a certain level of redundancy, right? And when things are redundant, they tend to break. But what you can do with this is essentially 4, 5, and then you get an int back. Is that correct?
Yeah, so currently the first default part of the
III. Exactly. So, this bit here should be something actually generated by the compiler, ideally. So, what you asked me for first was, can you make this happen? Because, you know, it's being called down here, right? So, it's all there. Well, you could, probably. You could, well, in fact you could, all right, but let's not get into that just yet. So what I proposed instead, kind of like politicians do, they just answer the question they want to hear. I said, why don't we do it this way? An int, and then we give this some kind of metadata to point out that it's, and maybe the name of the func goes in here. All right, and then we have a macro that will transform this into static var multi2 is a callable int. Callable int. You probably want it to be like so, and then does this. Okay. So you would transform this into that. Is anybody interested to see how that's working? Otherwise, I could answer the trickier question. But like we can look at this.
Yeah.
I mean, so this is the simpler thing to do. It's also nice in the sense that actually, if you open the class, you see this. So you actually know what the function is, which signature it has. It's not that bad. But indeed, you could be doing something. You could be wanting to do something like this. Okay. In which case, things might be slightly weird, but the way to do it is to find a trick to reverse order of things, because once this class is typed, like if we did this, then once the class is typed, we actually know the type of multi2, right? Because inference is going to figure out it's int. So this is great, now the class is typed, but this means we can't modify it anymore. So whatever we wanted to do here does not work. And the way to do that would be to give this some type of generic, let me just call it load, all right? Well, you're probably gonna be wanting the name anyway. Okay? And so when we encounter this, we want to remember that multi2 is to be typed at a later point. And so what this actually does, we would replace this by something like load with context, and we probably will want to, no, this is the main class, that's fine. And the name of the method is multi2. And then in load with context, I'm just going to write it down here, could actually use, for example, runtime metadata. So like once the class is fully typed, we could stuff into the metadata of multi2 something like, well, actually the real thing. I don't know, let's call it this, but using runtime metadata, which is going to be available, and we could just add this kind of stuff. All right, so this metadata that doesn't have 2 dots is kept and is available at runtime, and you can get it through Haxe runtime type information metadata, and then you could do stuff like meta get statics, I suppose, of the, yeah, C is just going to be a class. So you shift out some of the work into the runtime, which I guess is fair enough because it runs just when it boots. I mean, not sure this scales or is good or anything, but yeah. So you could do something like, yeah, then this is the context. The native name, and this is the field that we are loading it into. And then I guess statics, yeah, reflect.field, and this should in theory contain I, and that you can stick into the method that you had. So like, I mean, sometimes when order is really, really hard to deal with, the only thing that you're left with doing is getting the type information that you get at compile time, once everything is fully typed, and to stuff that into runtime metadata and to act with that. Like when you're creating complex routing mechanisms or something of that kind, it's often the last way to do it. Although in Haxe 3.3 we are getting a new feature requested by Kawe, which allows you to generate new types after all the existent ones have been typed. And this is supposedly running in a loop until you stop adding types, or it just will turn on your CPU cooler, depending on the flawlessness of your logic. But both things are very possible. So in that case, you might be able to actually generate a class that does the right thing. Like, for example, oh, hang on. Yeah, I mean, I hear on C++ it's expensive to have classes, right? Relatively, okay. Like, for example, you could. I guess the runtime option in this case is maybe one of the better ones, but it really depends. But otherwise, like during that phase, like after typing is done, and you can declare new classes, which you can do in 3.3, and you still have the old classes, you can do a lot of crazy stuff. Like you can exclude them, you can generate the new class on the fly, and you can use native to remap it. And then, well, if the stuff is compatible, then it will work. If not, then you will need laser unicorn magic. Okay, any more questions or stuff? Anyone wants to learn about? Oh, yes, maybe. So I think I did it in here, right? Yeah. So you don't have to do this. But your code may not compile without it. In the sense that the code really gets compiled into two different contexts, where two very different APIs are available. In the macro context, you can call into the hex.macro.context class to interface with the compiler. You can interface with the OS, with the file system, with all kinds of stuff. And in your target, that's not necessarily the case. In which case, you get the same kind of errors as within a JavaScript project you would want to call a Nico API. That's the kind of errors that you may get. And because with macros you, and this maybe wasn't the smartest design decision, because with macros you can just intermingle macros and ordinary functions in the same classes, the compiler sometimes does not really understand which part of your code was meant for which part, and then it tells you you want to compile something that's actually not available at runtime. And in that case, you need to insert the if macro. Okay. All right. Well then, I guess. Yes, it's a very good idea to generally. I mean, the compiler does not enforce a separation of macros and non-macros, but for you, it's. I mean, it's most of the time it's a good practice. Or if for the sake of a nice facade, of a nice API, you want to have your macros as part of the API that you're exposing the user to, you want to have some calls and some macros next to one another, then you can do that, but any other dependencies that they have, you move them out. Because that's cool. Like the compiler understands if there's macro in front of this, then it knows that in the actual context, not the macro context, it should not examine this. Like in here you can access the file system because it's a macro function. The compiler knows that you do not want to be using that code in your actual build, but only in the macro context. Then that's okay. But as soon as you have functions that are not macros, you need to make the compiler understand somehow for which context it's meant, and then it's a good idea to move at least them out. The macros can stay in, but the other stuff should move out, because otherwise the compiler just will try to build it twice and one of them will fail. Okay. Well then, let's call it a day. And all right. Thank you.
Is this available on GitHub?
Most of the stuff is, I'm sorry. So most of the stuff is really available on this GitHub repo that we created last year. Some of the fixes that I've done will need to be updated there, but yeah, most of it is there, and I hope that, well, this can be a growing resource to complement the rest of the things, but or maybe dissolved and put into the awesome documentation that we have. All right.